everyone, today we will discuss about the central force and motion in a plane. If a force acts on a particle in such a way that it is always directed towards or away from a fixed center and its magnitude depends only upon the distance r from the fixed center, then the force is called as the central force. Here, for an example, you can consider that a particle of mass m is moving on the circumference of a circle. So, you know that there is always acting a force on the mass m which is always directed towards the center of the circle. Mathematically, we can write central force as it is function of the distance from the center and unit vector r. You also know that unit vector r can be written as a vector r divided by its modulus, and let us say that vector f is equal to fr vector r upon r modulus. Let us say it is equation number 1. Now you must note that if fr is less than 0 or it is negative, then the central force is attractive, and if fr is greater than 0 or it is positive, then the central force is repulsive. Further, a central force is always conservative force if potential energy is function of the distance only. Then we can write the magnitude of the central force as equal to minus del V over del R. Here V is potential energy which is function of the distance only. In terms of the vector quantity, we can write the central force as equal to minus del V over del R unit vector R, or minus del V over del R into vector R divided by modulus of the vector R. Let us say it is equation number 2. Now if potential energy depends upon the distance, then the system possesses the spherical symmetry, and any rotation about a fixed axis will not change the solution. Thus we can say that an angle theta about a fixed axis will be a cyclic coordinate, and this results the conservation of the angular momentum of the system. You know that if theta is a cyclic coordinate, then you know that del L over del theta will be equal to 0. So from the Lagrangian condition, we know that d over dt del L over del theta dot minus del L over del theta is equal to 0. So we will have del L over del theta dot equal to constant, or we can say that angular momentum of the system is constant. Here in the diagram you can see that a particle of mass m is rotating about the z-axis having constant theta. You also know that the angular momentum of the system can be represented as r cross p. P is here linear momentum. As theta is cyclic coordinate, so we will write j as equal to constant. Now if we take the dot product of j with respect to r vector, then we can write it as r dot r cross p, and it becomes a scalar triple product, and there are two vectors equal, so its value will be equal to 0. So here we can say that vector r is perpendicular to vector j, which is constant. Thus motion of the particle under central force will be in a plane, and instantaneous position of the particle can be described by the plane polar coordinates r and theta. You can also see in the diagram that when a particle is rotating about a fixed axis, then it will constitute a circle, or it will constitute a plane, and the motion and the position of the particle in this plane will be represented by r and theta. So here we can say that instantaneous position of the particle will be described by the plane polar coordinates r and theta. Thank you.